Alright, hello and welcome to or welcome back. It's been a while. I haven't had the time to get a stream in, and I really haven't had the energy. I've just been extremely busy and just kind of worn out, so I apologize for that. But tonight we're going to get back into it. Hopefully this weekend. I got a few things I need to get out, and I'd like to get them shipped hopefully tomorrow, by the latest on Monday, and then get another batch coming in so we can get caught up here. Let's not waste a lot of time with the talking. Let's just get into it. So, first up, we have a SUB-12. I don't really know anything about this. It looks like it's a factory replacement. I mean, it's got a brand new LED plugged in. It's got speaker wires plugged in that don't look like they've ever been used. Either that or it's a really nice removal. I haven't seen one this nice, but anyways. I don't know what's wrong with this. I'm going to power it on and just check for the usual suspects. Basically just to see if we have power. I do see a tiny little bit of brown glue in there, so I know it's going to need some attention, but before digging into this one, let's kind of see where we're at, just because I have no clue. I want to see if at least we're getting power, so probably going to be a little rusty because I haven't done any of these in a while. Hopefully we'll get through. Hopefully I have all the parts. I did get a couple orders in. Still have a few outstanding, but we will make it through. Alright, as usual. It's impossible to see that screen. Let's prop it up with some alcohol. That always works. Alright, here we go. Let's fire it on current limited and see what happens. Hopefully nothing pops or blows up on me. Yeah, we need to make sure the power switch is on too, which it is not. On. Alright, let's see what we got. Try again. So we're getting power to the regulator, so the power supply section's working. Let's see if we're getting our 5 volts. And we're getting our 5. So it appears that this is going to be a refresh, preventative maintenance. So that's good. I do have several users, or owners, I should say, that do send me their plates and say, hey, you know, I've had this thing for a while. I don't want it to blow up on me, or I have a spare. You know, will you check it out and make sure that it's gonna last for me? And, you know, sure, why not? Everybody knows, if you've watched my videos, that these things do and will fail. It's just a matter of time, so why not get an update in there while we can? I hope this tape is not special in this bubble wrap, because it's coming off. This is like the protective stickers that some people leave on things. I'm a protective sticker remover. And I know that drives some people nuts, but I thoroughly enjoy it. Okay, problem number 1 we're going to run into is I don't have a screwdriver down here. I told you I wasn't prepared and a little rusty, so we'll get through it. I'm just going to have to do a little bit of running around. My screwdriver's upstairs. Let's see if I can take it off with one of my little ones, my little baby screwdrivers. Maybe. At some point I am going to have to go upstairs and get the bigger one. Projects galore. I mean, I've been so busy, my basement's even been suffering. Like, I haven't gotten any work down here done. I did get my fireplace moved downstairs, though. I don't know, in the intro, if you look hard enough into the darkness, you can see it. I have the lights off just because it's a mess over there, and I don't really need to broadcast my mess. Alright, I have to go get my screwdriver. So that's alright. That'll give me a chance to take a sip of my coffee and go grab my tools. So I will be right back. I haven't quite figured out why when I go to be right back it zooms in and zooms out. I'm gonna have to look into that. That's like zoomed way out. And it's a much brighter image. I'm gonna have to look into that. Must be something I'm doing. We're gonna use great grandpa's old school Stanley screwdriver back when Stanley was made in the USA and didn't suck. Old school. Some of these screws are a little difficult to get out. I wonder if this thing's been played with before. Very possible. The microphone's literally right in the way of my coffee sip. That's no good. Some of these things are fighting me already. Hopefully my pliers are down here. Yes. No, they're not. Not the ones I want. These plastic things are always a pain. They put glue on them, but sometimes you just gotta grab on them and pop them out. And glue's turning them a little brown there too. Definitely the right time to send this thing in. Like, I mean, I don't know if it's at any immediate risk of failure, but at some point this thing's gonna fail. Alright, three more screws here. And these screws that are into this heatsink are really in there. I don't know why. I've never had them this hard to get out before. Maybe they put some Loctite on them or they're stripped. I don't know. They are covered in my favorite white junk, though. And it does look like they had some Loctite on there. Or thread locker of some sort. Probably this plastic crap. We'll get it off. Do I need to get into that side of the amp? No. You know, another way of taking this off is just to remove these 4 screws in the heatsink bar, but I try to minimize my contact with the thermal paste. So I generally take it off the bottom here. Just gotta hope I don't strip any of these out. I mean, it's not a big deal. I can always put a larger screw in there, but I don't want to strip it out. Alright, I think we're good. I think we are good. Plenty of thermal goop in there, huh? Alright, let's clean that up. I got some cotton swabs stashed down here that I stole from the wife. Cotton balls work wonders on thermal goop. At least for the first, like, cleanup. I mean, they take makeup and stuff off pretty good too, so I guess they were designed for getting this crap off. But I don't want to get it all over my hands and all over my desk, so. Clean that up real quick, real good, just so I don't make a mess and drive myself nuts, and we'll be on the road to repair. Alright. Let's get into it. We're going to remove these speaker wires too. I'm going to throw these in the box because I guarantee I will forget to return them. These have those little locking tabs you got to depress, so you got to make sure you pop them in real good to get them out. Alright. Amp looks to be in pretty good shape. We do have some glue that's getting kind of gnarly. I see these little yellow capacitors are kind of wonky and out of the way, but we know the power supply works, so my main focus is just going to be to get the glue out. Got a little bit of glue back here. So we got glue in 4 places that needs to be removed. Not too bad. Always got to check our little green inrush. Make sure there's no immediate signs of damage, like a hole burned in there. Sometimes take a little light. Yeah, he looks good. So I don't think this amp has really suffered anything. I still don't know if it works with audio, but either way, the power supply needs to be taken care of, so we're going to do that, and we'll do all the preventative maintenance on the power supply, and then we'll go in and try it out and make sure that the input's working. I'm just examining the bottom to make sure nobody's really been in here and done anything that I'm not aware of. Doesn't look to be messed with. Everything on here looks pretty factory. That doesn't mean that somebody didn't do a phenomenal job, but it looks to be okay. Let's just make sure our caps are dead. After sitting for, a couple minutes, they should be, but I just like to verify. I don't want to wake up that quick. I did take a little nap after I got home from work today. I know that's lame, but like I said, I've been just really physically and mentally exhausted lately. Just too much going on and not enough time to get it all done, and I just wore myself thin. So I took a break. That's what you got to do. You know, you get tired and worn out, you take a break, chill for a little bit. That means people got to wait a little bit longer. Well, hey, you know, I apologize, but I got to take care of me first before I take care of your amps. Otherwise, there won't be anybody to take care of your amps. Things looks to be in pretty good shape. We're gonna have to do the Q5 update on this. It's got the old style Q5 in there. Might as well put the better, larger device in. I think that's the better route to go. I wish I had a better way of doing that, but there's really no other way. Got my little paper handy. I did make a board that fits on the back of this board, but you gotta remove the board, and I don't know, it's kind of a pain. Easiest way is just to take the old one out, put the new one on the pads, and epoxy it in place. Once that epoxy's on there, it doesn't go anywhere. If you wanted to be fancy, you could scrape the traces off and solder it to some of the existing components. I think everything on there has a leg that you can solder to, but maybe we'll play around tonight. I don't know. Waste a little bit of time. Step one, though, is getting this capacitor off. The big boy. Clean that hole out as good as we can, and then we're just going to whack it off there with a quick blow. I have to redo that one. A little bit of solder was left in the... Put some lead in there and try again. Sometimes this lead-free just doesn't like to cooperate. It's a little better. So to get this thing off, I like to just take my screwdriver and just karate chop it right off. Pops right out. These Carly capacitors are like folded over. I think I'm gonna remove these too, just because I don't know, it looks kind of lame the way they are. I don't know if I'm gonna be able to get those out. Probably not with this large tip. And I don't need this large tip anymore, so we'll switch over to a small one. I got a new tip, but I'm not ready to switch it out yet. These things are stupid expensive for a little piece of metal. Alright. Oh, that little jar of water's hot just from cooling that tip down. I've been trying to keep some spares just because I know eventually I'm going to have to, but I got a brand new number 6 tip. But I think this one's got some life in it yet. And I usually take them up to the wire wheel and polish them up and clean them up, you know, every once in a while, just to extend the life even more. So yeah, I'm gonna pull these two Carlys, make sure I get all the glue out of there, and then I'll put those back in, and hopefully they'll sit up straight. If you wanted to, you can move them to the bottom of the board too. That is an option. But I don't like this one that's in here. It's in there crooked, and that bothers me. Does not make my OCD happy. Therefore, it must be changed. Having the right tip definitely does a much better job of cleaning out these holes. Putting some lead on there helps too. Lead-free solder sucks. I mean, if it's all you got to work with, then hey, I mean, that's what you got to work with, but I think leaded solder is far superior to lead-free. Just using the nippers just for like a little gentle persuasion, just so I can get the part off the board. And just scraping some of the glue off. I don't want to cut the capacitor or cut into the case of it. I just want to get the glue off. That's all I care about, is getting the glue off. So, I mean, some of it's going to be left on there. You can't get it all off. It's not even worth trying. We'll measure those two before we put them back in, but they're probably good. Let's get well, let's take all the caps out. Might as well. I'm heated up, and then I can just turn the iron off and roll with it. This guy's the hardest one, because they left almost no clearance on the solder legs. The holes are undersized as far as I'm concerned. Very hard to clear those holes. Even with a, I mean, this is a top of the line solder sucker. I mean, the only thing better than this is going to be probably the Hakko Complete Station, the Hakko pistol grip. But you're going to seriously pay for those. I have a Hakko pistol grip, I just don't have the power supply for it. Well, that's the best I'm going to be able to do. You always risk tearing the through holes out when you do this guy. We got it. No through hole tear. The cap didn't survive though, but I don't care about the cap. Alright, let's... you know what, I'm going to cut these off. I don't want to, I'm going to minimize through hole repairs tonight, so I'm just going to cut all the caps off. And I'm going to place them in order in my little mat here. You would think I'd have these memorized by now. I've done so many of these, but I don't. But I'm cutting them off because I don't want to have any damage on the board, or minimize it as much as possible. And you know, I'm not saving these caps, so I really don't care. And of course, these ones are soldered down to the board better than any caps that I've ever had on a SUB-12 before, because I can barely get the things out of there. That's the way it goes. But yeah, by cutting them off, I'll be able to pull the legs out and minimize any chances of damage to the board. And like I said, I just don't, you know, I don't want to deal with it today. This guy's glued in, so we're going to get the glue out first. So we're in good shape. I'm going to shut the solder sucker off for now while we work on the glue. And then Here, we'll get the glue out of there. I'm missing my razor blade. That is not going to be good. Might have to make, well, I don't even know where that thing is, so I'm actually going to have to do without it for now. I'm sure I borrowed my tools for some project that I got going on upstairs, and so we will go with dental pick and dental scraper. I have new razor blades, but I hate using new ones because they really tear the board up. I like my old self-sharpened dull blade. And I mean, dental scraper will get it off. It's just going to be a little more work. I'll make a note to myself to hunt down my missing blade. You know, typical glue removal. We're going to use some heat, get it heated up. I go to, right now it's set at 107 C, which is, you know, warm but not hot. But the glue gets real soft when it heats up, so it makes it pretty easy to remove. I think the dental pick is going to work better than the scraper, actually. You know, the board doesn't need to be spotless. It just needs to be free of glue by any electrical traces or contacts. You can pump the heat up a little bit if you're impatient, but it starts giving off fumes, and I don't know what's in those fumes, so I breathe enough shit in. I don't need to make it any worse. So I prefer using lower temperature and a little more elbow grease, but higher temperatures does make it more gooey and easier to get off. Main thing is, you know, anywhere there's a through hole or a trace, you want the glue to be absent. So that's where it's going to end up shorting out and giving you problems. Alright, there's one spot done. We gotta do in here, all around the dashboard, and then we gotta do this little spot here. We don't need to worry about on top of the pots, but we have to worry about on the board. The glue that locks these pots in place should be fine. We're not changing any of the outputs, so we're not going to have to adjust the bias. There's one little spot over here by this, looks like a varistor, that needs to get checked out too, so. Turn my air up a little bit, leaving the temperature the same, just turning up my air delivery. Stuff stinks. Even at 100 C, the glue still smells really bad. And there is a lot of it in this part of the amp for whatever reason. They really... Some of these caps have nothing on them, some of them are just totally buried in glue. Let's see if I can tweezer some of this out. Sometimes getting a tweezer in there and rolling it around is effective. I think this is just going to be one of those cases where you just gotta work it out. I like to say the ones that don't have any glue are like built on a Friday. You know, the workers were worn out and tired and lazy. This one must have been built on a Tuesday. 'Cause there's a ton of glue. Once you get the board hot, you can kind of poke around in there a little bit, but it does cool off pretty quickly, so if you're not fast, it's going to harden on you. Definitely one of the worst ones I've worked on in a while, glue-wise. Really hoping I don't have to pull the dashboard just to clean the glue. That would kind of annoy me a little bit. Alright, that cap is free to get removed. Just a ton of glue back here. And the unfortunate part is this glue all has to be removed. If it's not all removed, I'm going to be getting a phone call from this guy like, hey, my amp blew up again, or my amp blew up, you didn't fix it. So we got to get the glue out. We got to be careful because there are parts on the board down here. You know, we don't want to damage any of these little some small through hole parts. So we just want to make sure we clean up around the legs really good. Try not to get too much heat around the large film cap, because it will damage the cap. There's a little capacitor down here, you know, you don't want to damage him. I mean, in some cases it might be, you know, unavoidable. You might have to sacrifice the cap on the board to get all the glue out, but if you're careful, usually you can clean up around it real good. It's okay to push parts out of the way if you have to too. Just, you know, bend them over. Just get them out. But this is the tedious part that ends up being the most rewarding, because this is where you get, you know, 95% of your fix from. If you took a brand new amp and you just took the glue off it before you even plugged it in, the amp would probably last, you know, a decent amount of time. Even cheap Chinese caps, you know, will last if they're not exposed to any stuff. And be careful around the cap. You don't want to pierce the case of the cap, but we got to get all this crap out from underneath it. Or at least as much as we can. Good enough. So what we have left is a little bit around the ceramic cap on the board that's on the legs. Just clean those up. I don't care if it's on the top of the little ceramic cap. The ceramic caps are the little, like, yellowish orange colored ones. Those you don't need to be too careful around. They can usually tolerate the heat. But, you know, do the best job you can. Don't half-ass it. The most important is the dashboard. That glue there will kill the samp. And there's generally a lot of it under there if they, you know, glue it down as good as they glued this one. So be prepared to put a little bit of time and work into getting this out. Time, work, and heat. There are a couple of resistors and capacitors on the board here, so be careful there too. You just want to kind of clean around the legs of the through holes and then just kind of rip it out. This might have been a good case for a dashboard removal, to be honest, because it really was under there. It would have made it easier to clean. I don't know if it would have saved any time or not. But this would be one scenario where I could say that it would be probably okay to pull that out, just because, I mean, there is a ton of glue under here. I think I got most of it. Still two spots. Two spots I'm not comfortable with, and they're right behind the little bit of residue that's left in there generally isn't going to be, you know, too hard on you. But you want to make sure that all the chunks and everything are gone. So, you know, if you have to, you can bend that board a little bit, get it out of the way so you can get a look down in there and see where you're at. We had a lot of glue on this board. Be careful when you're using the pick on the back of the board, because this board does have a trace that runs along the back. You know, it's okay if you scratch it up a little bit, but don't scratch it up a lot of bit. Dental picks are almost a must for doing this. There's no easy way to do it. I'm going to hit that with the wire brush a little bit too, just to, if I can get it in there. just to get any little bits of residue off of there. Alright, so glue is cleaned out. You know, there's a little bit left on this little ceramic cap here, but that ain't gonna matter. It's not shorting anything out. This ceramic cap looks alright. There's a little bit on the side, but you should be okay. Yeah, it looks alright. So we have one more spot we gotta get, and that's right here. Oh, I got gooped. Never fails. Alright, so then after we get this bit of glue out, I'm gonna cut this cap out too. Let's get that guy out of there. And you'll see why, I don't know, I think I've done it in other videos, but you'll see why I'm cutting those out. We're just hedging our bets that we won't damage the board. That doesn't mean we won't damage the board, but it generally helps. So we don't want to get our pots like super heated. We just want to get the glue warm enough to where we can get it off the board. It's a really awkward angle to work at too. This section of the board does get hot, so if the glue is touching that, eventually it's going to short something out. So I'm going to take the pick and kind of just like pull the glue off the bottom of the pots. Get it off the board. And you can see it, like when it gets to the right temperature, it gets kind of like fluid, and it starts kind of sticking to itself. And I'm just gonna slowly and carefully just work that off. Like I said, we're gonna leave it on the top of the pots. There's no way to get that off without damaging the. I mean, you can, but you risk damaging the pots. And I don't have any pots right now. And with the way orders have been, it'll take me 2 months to get them, so I'm not risking that. I just want to get it off the board. Off the board and out from under the pots. Tweezers are kind of your friend here. I know that's not the most convenient way to do it, but alright, so we're cleaned off of the pots. Now I'm just getting a little bit of the last residue off the board. You know, you don't have to go crazy with the board either, because you'll cut right through those traces and then you'll be screaming. Like 80% is good enough. Alright, now we have a clean slate to work with. You know, as far as I could tell, the glue in the trouble areas is resolved. First thing we're going to do is the Q5 upgrade. And how can I get you some light in there so you can see? I'll zoom in a little bit. I don't know if you're going to be able to see with my head in the way, because I'm sure I'll be leaning down, but We'll try just for the sake of doing it. Why not? What I need to do is move the camera, but if I move my camera, then my head's going to be in every shot. I've been trying to minimize, like, you know, showing off my bald spot to the internet, so. This is the guy we're going to replace right here, Q5. We're going to cut him out, then we're going to put a TO92 through hole in there. And we kind of need the light to see what's going on. And I need my razor blade, which I don't have. Alright. Alright. I will use one of my new blades. Mainly because I don't know where it is and I don't want to waste time tearing through the house looking for a razor blade. But with a new blade, you need to be exceptionally careful because this thing will just slice right into the board. This is a Hobby Lobby. Hobby Lobby or X-Acto blade holders suck. Alright. I mean, yeah, it's a sharp blade. So, yeah, I gotta be really careful. What I want to do is I want to cut the legs off and then desolder it. We want to cut the legs without cutting the board. There's one. Actually, that was the side with two. And it's off. I still don't know if there's any trace damage. I won't know until I heat up my iron and try to pull the legs off. But we cut it out. I know that's hard to see. So let's cut out. What I'm going to do is clean the pads. Get the remaining little legs off the pads. And it'll leave a little solder ball on there. That's okay, because what we're going to do is use a little wick and flux to clean that up. I normally don't use flux, but I'm using a little flux today because I don't want to. I'm doing everything I can to minimize board damage. Because I got a couple amps I'd like to get through tonight. And if I have to do excessive repairs, it's just not going to happen because I'm going to get tired and I'm not going to want to do it. So, we're being careful tonight instead of cowboy. This is much easier to do with the bashboard removed, but the bashboard's working, so I don't want to remove it. Don't grab copper when it's hot, too. Rookie mistake. Alright. So we didn't destroy the pads, we got lucky. Even if we destroyed the pads, it's not, you know, the end of the world. I will zoom in and we will take a look at this together as soon as I get it cleaned up here. A little bit of rubbing alcohol to remove the flux and the residues and clean it up. Alright, let's zoom into the max. Light really doesn't like to behave in there. So you can see where I removed Q5. You know, there's some shiny pads there now where the device used to be. So there's Z2, you can see it's on there, and there's the pads for Q5, nice and cleaned. If you tear one of these pads up, which you're very, very highly likely to do, you can still reconnect this, because the front pad goes on a trace to here, and then that trace goes to one side of R55, and the other side of R55 goes to this pad, and then this pad here connects to one of the pins on here. So if you really screw this thing up, you could just go across R55 and then take your last leg, and I think it's pin 5. I'll verify. Pretty sure it's pin 5. It is. 1, 2, 3, 4, 5. So if you totally screw it up, you could just put it across R55 and then to pin 5. Let me you can do it either way. If you do it that way, it might be a little bit more work trying to get the legs to fit in there. But we'll cut here. I'll just do continuities just so we can verify without using the magnifying glass. So there's one side. There's the front one. Yeah, so it goes across R55 for the front two pads. So if you screw up your surface mount pads, you don't need to freak out. It's definitely fixable. Let's find our T092 transistors. Geez, I don't even remember where anything is. I'm losing it. This is a 4401, 2N4401. Thought I had that written down somewhere. It's on the schematic. The one on the board is an MMBZ 4401, which is just the surface mount version of it. But on the latest revision of this amp, they use a higher wattage transistor because the heat dissipated through it would cause them to burn up. So alright, the flat side faces the dashboard. Collector, which is going to be the left pin, goes to the top. Base, which is the center pin, comes out towards me. And emitter is back there. So I just duplicate the footprint and then put them right back on, and then I blob it up with epoxy and glue it in place. And once you have the epoxy on there, it ain't going nowhere. It's a little tedious. I mean, you're putting a through-hole part onto surface mount pads. Seabass asks a question here. What would happen if you put a 12-inch driver from a car sub in that thing? Nothing. It would work. These are pretty powerful amps. It wouldn't sound right unless you had the correct box for it, but it would definitely make bass. It depends on the enclosure. If you just have if you're talking just like a car audio enclosure, with a 12-inch sub, you know, yeah, it'll work. You're gonna have to find a way to power it if you're gonna put it in a car, though. Maybe for like a mobile home or something, it would work. But if you're just trying to replace the driver in your sub that you already have, I would try to stick with something that matches the specs of the original woofer to get the best sound. But people do it all the time. I mean, I don't know. I've seen plenty of off-the-shelf subs with Pioneer woofers and all kinds of stuff in there. So You know, there's no real wrong way. It's just the preferred method is to try and match the driver to the enclosure. But I mean, you can power any sub with this thing. 300 watt amp is a 300 watt amp. That's RMS. Oh, we almost got a 2-for-1 on that solder job there. We got one leg and we gotta get the other one. So this is the hard part, getting the legs to go where you need them to go to solder it down. And I need more light, so I gotta block you guys out. And I know it might be a little difficult to see. Yeah, I think I ripped one of the traces loose. Which won't hurt anything, but once we get the glue on there. Next one of these I do, I'm going to go across R55 and see if it's any easier, because this is kind of tedious soldering it like this. Getting everything to go into place and fit where it's supposed to go, and making sure it doesn't pop off, and then gluing it down. This is the wrong tip too. I should probably just put the right tip on there. That will tremendously help things. Instead of having that giant hoof tip in there. Alright. Transistor is in there. Yeah, it's nice and stable now that all the legs are soldered down. Next one we do, we're going across Q5. See if that's easier. It probably won't be any easier to do, just because of the way that it is installed in there. But maybe, you never know. Hearing a weird noise in my house right now, and it's driving me. Oh, spilled alcohol. That sucks. Luckily, it'll evaporate, but it still sucks. Told you guys at the start of the video I was rusty. It wouldn't sound bad because of the enclosure. Like, it depends. Like, I have like a Sunfire 12-inch sub, and you know, it's a really powerful driver. It can handle a lot of power. If it was left in the Sunfire enclosure, it would sound just like the Sunfire. You might not be able to get the SPL out of it, but I mean, it would sound fine. If I took that driver and I put it inside like the SUB-12, it's probably going to sound like garbage, because the enclosure is tuned to the parameters of the woofer. So every woofer, you know, has a different volume requirements and box requirements for the frequency range that they're, you know, designed to operate in. So to say, you know, I don't know what the exact numbers are. Say that the enclosure for this SUB-12 is tuned to 34 hertz. If you put a Pioneer driver in it, like a Car Audio Pioneer or Rockford or, you know, whatever driver, it's going to change that tuning. So the tuning might go to, you know, 40 or 50 hertz. So the whole frequency range is going to be changed. You know, it'll work just fine, but it's not going to sound nearly as good because the enclosure is what really, the enclosure matched with the driver is what really gives you the sound. The amp doesn't matter. So if you have the right enclosure matched to your driver, I mean, you'll get phenomenal sound out of it. And you know that a lot of people knock Bose and, you know, give them a hard time because their prices and, you know, their marketing and that. But one of the things that Bose does really well is enclosure design. So they can take a, you know, a 4-inch woofer and put it into like a waveguide box, and you can get an incredible amount of sound out of a little woofer. I mean, you're not going to shake the house down with it, but if you're listening to music, it's going to give really clean, tight bass because that enclosure is matched to that speaker. So, like if you have an enclosure, and there's like tools online you can download that, like you can make an enclosure based on the parameters of almost any speaker. So, you know, if you want to do your own sub, and I've done this before. I've built my own subwoofers, you know, and when I'm Parts Express, I bought a good driver, like a Dayton driver, built the box recommended, you know, volume and size and port, and then used a Klipsch amp to power it, and it sounded great. So, um, it all depends on what you want to do and how you want to do it. But I guess the short answer is it'll work. It just might not sound how you expect it to sound. Maybe I'll try that, you know, messing around. I have a lot of Sunfire stuff I have to get into. And the Sunfire HRS-12, it's got a real powerful amp into it, but when it, you know, when you do all the math and numbers on it, it's really just a 450 watt amp. You know, they claim it's like, I think it's 1250 watts of dynamic power, but it's really not 1250 watts. It's really 450 watts. But they kind of cheat in the way that the amp is designed. It can output like bursts at higher power. I wish I didn't spill alcohol everywhere. I get high down here. Alright, so Q5 has been upgraded. Now we got to put the caps back in. So I'm going to clear out all these through holes here, and then we'll start soldering everything back in. And hopefully this will come back to life and be ready to go. I'm also not sure why. Like, I'm looking at my window here, and it says that I'm streaming, but I have nobody in the view. So if you ask a question and I don't answer right away, just bear with me because it says nobody's in here right now. I don't know if that's a computer issue or a YouTube issue. I guess I could just refresh the page, right? Let's see what happens if I refresh the page. Nothing, because my mouse is dead. Really? Yeah, unfortunately, all Klipsch amps use these cheap Chinese caps. I think these are Junfu's. No, what are these? This one, actually, the main cap's not. Yeah, actually it is. I don't know what brand TF is. All the other ones are Junzl, Junzl. Cheap Chinese caps. I still don't have a mouse. I don't know what happened to my mouse. Let's see if I have keyboard mouse. There we go. I'm going to try and refresh the page really quick. Hopefully I won't go anywhere. Everything came back, but it still says that nobody's here. So, well, if you're here and watching and I don't see you, I apologize. YouTube must be running on cheap Chinese servers tonight. But yeah, the caps, they're junk. You know, there's no other way to say it. They're just garbage. They'll work. I mean, in reality, these were designed to be cheap consumer products. Like they sell them at Best Buy and Costco, and um, they do that so they can remain competitive in the market. With selling by volume versus selling low volume, high quality stuff. But aside from the cheap circuit boards and the cheap caps, it's a pretty good amp. So once you fix the flaws on it, you got yourself a really nice amp and a sub that'll last. So most of these that I get in, the problem is the glue that fails. I could probably leave the capacitors alone, and you might get another 5, maybe 10 years out of it. But since I already have the amp mostly apart, I'm just gonna I put Japanese caps in. I like Nichicon. I think they make, very good cap. Nichicon, Rubicon, they're tier 1 caps, which means they're not junk. The same size caps, but they have better ratings. I don't know if they don't have the temperature rating on them. But I use caps that are rated for higher temperatures so they last longer. And I purely use Japanese Nichicon caps. I think they are, among the best. The bad caps forums, rate them pretty high. I've never had any issues with them. So fast, heavy music. You talking like metal or just hard rock? Fast and heavy music, I'm going to say you probably want something smaller if you want fast and heavy. So I would say probably stick to 10-inch, and I would go with 2, so you can get more volume, more sound pressure out of them. When you start going like 12 to 15s, the response starts to slow down. So I mean, you can get a lot of bass out of the larger subs, but the larger ones are definitely better at producing, slower, low tones. I would say any of the Klipsch 10-inch really. I like the what is it? The RW10D. If you can find those on eBay, those would be good buys. The amps would have to be gone over. Sunfire HRS 10 would be a really good buy. That'll be a little more expensive, but the Sunfire HRS 10s are pretty good. The Sunfire True MKs, I think those are 12-inch, but they have really thick surrounds on them, so they're going to have a little bit quicker response because the excursion isn't going to be too crazy. Velodyne Digital Drive 10, that would be a good one. These are all older subs. I'm not too familiar with the newer stuff. The Klipsch R110 SW would be okay, but I don't like the way the amps operate in those. And if you want really clean bass, I would stay away from them. Those are more geared towards movie. I would say stick with the older stuff. The older stuff you're generally going to get better sound out of. I think if you went with 2 RW10 or RSW10 Klipsch subs, you'd probably be pretty happy with that. I would do one in each corner of where your screen is or your TV, and then kind of tune them to where your listening position is. But I think 2 of those would be definitely good. If you want like crisp sound, you can even go smaller, and you can go with like 4 8-inch. It's a lot of overkill and redundancy, but then you can put one in each corner of the room. But you got to be careful about phasing issues. I know Sunfire makes Super Junior, which is like a 8-inch, and my room upstairs is like 16 by, I think it's like 16 by 21. And I had one Super Junior up there, and I mean, it really did a good job. But I also have a huge picture window, and that picture window, you know, there's a node off of that window, so I get some gain off of it because that window actually starts to vibrate. So it really depends on the room that you're going to put them in, and you know, the placement. But I think 210s would be perfect for fast, like heavy rock. And they would be good for movies too. I like, you know, I'm not so much on house shaking bass. I'm more of like, I want to hear it and feel it. So 210s, 212s would be the ideal range. If you do movies more, I would go with 212s. If you do music more, I would go with 210s. A lot of people like SVS. You know, people talk about those all the time on the forums and Facebook groups, but I don't have any experience with them. I assume they're probably good, but I've never heard one, so I can't really recommend it if I've never heard it. But a lot of people say they're good, so there has to be some truth to that. The main reason people knock Klipsch amp or subs is because they have these amp issues. That's generally why they kind of catch a bad rap. Not hot enough yet. Two of these old Synergy sub-10s wouldn't be a bad way to go either. I'd probably go sub-12 if I went with the Synergy though, because I think those are downfiring. Downfiring, you're relying a little bit more on the port. And room placement is a little more important with downfiring as well. You don't want to place them really close to the wall. You know, another thing you can do too, if you wanted to do something totally off the wall, is go with a couple of sets of Logitech Z5500s. I know that's not a very popular home audio application sub or setup, but they got 5.1 built into them. You can run them, two of them in parallel. That would give you 10 satellites and two 10-inch subs, and you can pick them up pretty cheap, used. And I mean, they produce a lot of bass and pretty good sound, especially if you upgrade the satellites. I use one in my living room right now currently as a 5.1 setup, and I really like it. Mainly just because I don't have to have a huge 5.1 processor in there. That's the main reason why I like it. But I've modified it so I can hook up external subs to it and more satellites and run two of them in parallel, so it's not like your typical application, but those things throw out some punchy bass. So what I'm doing now is I cut all the caps out, and now just removing the leftover legs from the cut caps. And I'm doing that with a pair of tweezers that are a little bit magnetic. And they just suck the legs right out. This way I'm not stressing the board out. This is a known weak spot on these boards. And the through holes just tear right off, so I'm trying to be a little careful. And not give myself any extra work. I just don't feel like doing through hole repair tonight is what it boils down to. That one does not want to come out. Wants to fight me. You gotta be careful you don't put too much heat on these through holes. They will just disintegrate. But we gotta get the legs out or the new caps won't go in. Let's see, we got 2, 3 more, 4 more. One up here. That's the filter cap for the bash supply. This just runs off an auxiliary winding on the transformer, a little 35 volt winding. We feed that through a diode and clean it up with this cap. And the other ones that I removed are power supply. And then 2 audio caps. Non-polar. Keep forgetting where this guy is. So yeah, if you want to minimize damage to the board, it's always better to cut off the caps. I mean, we're not reusing them, so why bother with these bent leads and all the headaches that come with them? I'm putting a little lead on here just to help the solder melt. Alright. Now it's recap time. So I have 2 different sizes of these Nichicons. Doesn't really matter which ones you use. I'm going to use the skinny one. They're the same exact cap. They're just different can sizes. One's fat and short, and one's skinny and tall. Doesn't matter which one you use. I like to use the skinny ones because it gives the Carly caps a little more room. These the SUB-12s use a 560. The SUB-10s use a 470. I'm gonna like quadruple check to make sure that my soldering job is good on that transistor, because I do not want to try and get in there after this cap's in there. And I said earlier in the video we're gonna measure the Carlys, so we'll definitely do that. Make sure you put your big caps in the right polarity. If you put them in wrong, you will be sorry. Alright. Cheap Amazon cap tester. But you know what? It's a good one. 0.1, that's what we're looking for. Go into that, it should be 100 nanofarad. 99.8 says good to me. These generally don't fail in this series of amp. They're not by a high heat source, so usually the film caps are good. I call them Carly caps just because that's the name of them on the top. But if you remember in the beginning of the video when I pulled these out, one of them was like laying on its side. And now that we have the smaller electrolytic in there, they sit nice and straight. Alright. So I'm going to tack one of the legs in there. They're still going to be a little bit funky because there's some glue on the bottom. Well, we want to get them as straight as possible. Make it look nice. Not that anybody's ever going to see it, but I still like to make them look nice. I had Chipotle for lunch today, so expect to be muted a few times as I'm working here. So, you know, pulling them out and cleaning the glue out. The caps are sitting flush in there. There's a little bit more room. It's not rubbing. They're not getting bumped out of the way by the big monsters. So we can throw those in the scrap bin. We need a 470 with leads. I gotta check the voltage on that. Was it a 100 or 160? 160. This is my last 160. At least my last small 160. I got some monsters. That I don't even know if that one will fit. I do have some 200s. Looks like I'll be placing another order this weekend. That sucks too, because capacitors have gotten so expensive in the last like 4 months. Prices are just through the roof. Luckily, the leaded ones are only used in these amps, so the other amps I'm going to do tonight don't need those. Actually, you know what? I'm just going to pause really quick and put those in my cart before I forget, because I know I'm going to forget, and then I'm going to be upset. So just give me a second so I can go to DigiKey here. Because if they're on back order, it's going to take me a couple weeks to get them. So bear with me, I apologize, but this is important. I still don't know why my mouse stopped working. That's driving me nuts. Let's see, we want 470 microfarad. At 160 volts. And we want Nichicon. Or Nishon, or I don't know how you say it. I need somebody that's like Asian to tell me how to say that right. This series is UVY. Please be in stock. None in stock, of course not. Because I need them, they're not in stock. So I know this is delaying the video, but I have to do this. Lead spacing is 7.5. Let's see what we got in here. It's 7.5. UPW, that's in stock. UPS is in stock. I need can size. What can size? 22 millimeter diameter. Diameter is important too. Yeah, the 22 is going to be too big. These are 18. I think I'm going to be in trouble with caps. Nothing in stock from Litecoin. Now I'm in trouble. That sucks. It totally sucks. Alright, well, gotta go to a different brand. Let's see what we got. There is nothing in stock anywhere. Not even different brands. Rubicon's out, Chemicon's out. I hate to go to the lower temperature rated caps. Well, I guess I'm going to... what do you do? What do you do? What do you do? I guess I do nothing. I'm going to have to pause all my orders because I can't get parts. I mean, that's insane. I should share my screen right now and show this to you guys. I wish my freaking mouse was working. Capacitors are out of stock pretty much across the board on DigiKey. Let me check Mauser. I mean, I try to keep a pretty healthy stock of these things, but you know, $4 or $5 a piece. I can't keep 100 of them on the shelf because if I don't use them, I'm wasting money. Plus, I mean, I don't have that much money for my hobby budget to spend on that. Aluminum capacitors leaded. These are these axial or radial? I think these are axial. We'll know right away when we look at the picture. And no pictures, yeah. We want radial, not axial. I hate Mauser's component search. It sucks compared to DigiKey. Surface mount. Screw terminal. They're not snap-in. I need through hole. I guess maybe they will be snap-in. Nope, no, I see radial leaded. DigiKey or Mauser website sucks. They do offer first-class shipping though, which is nice. So you could save a couple bucks on shipping, but navigating their website is not fun. All right, let's see what they have. 470 microfarad. at 160 volts. They show a couple in stock. Let's see what happens when we go to lead spacing 7. Still looking okay. Let's try diameter 18. So they have UVK. Are those 105C rated or are those 85? 85, of course. But they do have 15 of the ones that I need in stock, and they're not getting replacements again until October 13th. Everything else is out of stock. UCY series is January of 2023. I don't even know what that brand is, so I'm not going to order them. Wow. Well, I'm going to place this order right now because they have 15 in stock of the UVYs, and I believe this is a UVY. Got to get them. And the price is pretty good right now. I'm ordering them right now. Continue to shipping. I'm going to clean them out because they're not going to have them probably till next year, which totally sucks. See if I can get first class. Save a few bucks on shipping. Nope. We'll do FedEx. I don't like UPS. UPS is the worst shipping company in the world. $8 to ship them. What a crime. Oh, I gotta log in. Sorry I'm wasting time here, but I need to get these parts or I'm screwed. I need to make sure they're sent to my house, not sent to work. $15 left for the rest of the year, and I managed to somehow get them. It won't ship out till Monday, but that's okay. FedEx Ground. Do they have my credit card saved? Shoot, I don't remember what the number is. I think that's the right card. Continue. Alright, sorry about the delay there. I needed to order capacitors. Yeah, MacBook Pro, dude, we're in trouble. I got the last 15 of these guys here. So hopefully they'll be here next week, but that means I can repair 15 more sub-12s for the whole rest of the year. Everything else is out of stock till minimum of October. So, and chances are, you know, once those hit, they're probably going to be back ordered and gone. So it's looking like 2023 for any more of these amps. And I don't think I have anything else that'll fit in here. The 200 volts are 10 millimeter lead spacing, so I mean, I guess I could stuff one in if I really had to, but we are definitely in trouble. At least for this amp. And I'm not going to go and put garbage caps in. I won't do it. Send your amp to somewhere else if you want junk caps in there. That is not my style. That totally sucks. But yeah, sorry I had to delay the video there, but making sure that I can at least stay a little bit in the game is important. Whose amp is this? Is this Curtis? Who sent me this? Jeremy. This is Jeremy's amp. So Jeremy, you got the last capacitor. You may be the one of the few that get your sub-10s and sub-12s fixed this year. So these legs on the larger through-hole legs, I always double solder them. So I do them once with the iron just to kind of get it tacked in place, and then I do it once with the big boy to make sure that I get a really nice fillet on there. It's going through a lot of copper planes, so you want to double hit that so it looks nice. It kind of looks like crap now just because there's flux residues and stuff on there, but I promise you it's a good solder joint. I'm going to have to go through my cap stash. I'll probably do that tomorrow. Go through and make sure that any of the other little weird ones that I need are at least in quantity of 50. Alright, now we can start repopulating the damaged ones there. $47.50 and $125. All right. There's two different cap voltage ranges this board uses too. Some of them use 25s, some of them use 35s. I generally always use the ones that came on the board. So if it had 25s, I put 25s back in. If it had 50s, I put 50s back in. I'm running low on these too. My 47 microfarad. Let's see, extra. I have a few squirreled away. Yeah, so I have some extras of these, about 200. It's one of my most popular caps, so I made sure I ordered. Last time I ordered a big batch of them, just so I wouldn't run into this issue where can't get parts. But I deal with this at work every day. Like, I get a call from manufacturing like, hey, we can't build this thing because there's no parts, and it's my job to figure out how we can keep production running. And I'm not even an electrical engineer, but that's what I do now. That's how bad it is. Things are bad when you got a mechanical engineer doing the job of the electrical engineers. Things are really bad. But I actually enjoy it. I enjoy it more than my regular job, so I've been doing it. Luckily we have plenty of caps, the smaller ones. This is the tedious part of the job. Just making sure all these get put back in and I don't bend the leads on them, but I do let them get like V'd out a little bit. Just because it kind of holds them in place. I don't slam them all the way down to the board. And the way that they go in, it starts with the dashboard and it goes 47, 100, 47, 100, and I think it's another 47, then 100, and then the 2 films. So they alternate, but I can't ever seem to remember that. But these are important caps. These are filters for the op amps, so you don't want these screwed up. Anywhere it connects to the ground plane, we're going to double solder. Make sure your polarities are correct too. Square pads are positive. I've screwed that up numerous times. If you screw that up, you got to replace the cap, because generally the electrolyte starts to boil when they're put in backwards. Let's see, 100, I need one more 47. 4700, 47. Oh, see, I screwed up already. I think I did anyways. Is that a 100? No, it's 47. Talking too much. 4700, 47. Yeah, this one's got to get shifted over. But luckily there's fresh solder on there, so they should come out really easy. Let's redo that. Alright, this one's 100. I mean, it's not critical. It's not going to cause the amp to explode or whatever if you had them in there wrong, but it's going to bother the hell out of me, because it ain't right. Alright, gotta make sure that my view is in camera too. I sometimes forget that. Alright, so we have one more 100 and 2 bipolars. And I know one of them's a 4.7. I don't know if they both are or if one of them is a 2.2. That I can also not remember. It doesn't really matter how, neat your soldering these on here right now, because like I said, I'm going to go over them again with the higher wattage solder sucker, just to make sure the ground planes are all soldered in really good. The legs that don't go to the big ground planes, generally those are going to have a pretty good solder on them, so I don't worry about those too much. But if it connects to the bottom, I just hit him with this guy real quick. I don't turn the suction on. I mean, if you really wanted it, you could do them all too. Why not? Let's just do them all. You're just putting it on there for a second and just letting the heat really flow that joint, and it gives you a really good flow to the top of the board. I've been doing this more and more. I know it's a lot more work, but you get a really nice fillet on the top of the board. Every single one of those has a beautiful fillet on it. The factory ones, the there's no caps left in there, but a lot of the factory solder joints on here, you can actually see into the through hole, like, because it's just a cheap wave solder that they do on there. Let's see, 4.735 bipolar times 2. So yeah, just to make sure that the work isn't cheap, I've been doing that more and more. Anywhere where there's a ground, if there's no ground planes and you know the solder flows in there good, I don't do it. It's not always necessary, but like these two, these just go to traces, so I'm not really worried about them. I know that the small iron's gonna do just fine. But anywhere where you have a lot of heat getting sucked out of the joint, it's always better to make sure that you got a good attachment point. Now I see something on here I don't like that I'm going to actually fix. The legs that were bent over on these two parts that are close to this cap are, you know, fractions of a millimeter away from this leg. Good solder joints on top too. So I'm going to snip these leads, and just because to me it's a little too close for comfort, you know, in reality it's probably never going to touch, but there's no reason why it needs to be that close. So I'm just going to bend it out of the way and just give it a little snip. Now it'll never touch. You know, is it an issue? Probably not. Am I OCD? If you've watched any of my videos, definitely you know. But yeah, I don't know. Like, it takes what, 3 seconds to straighten that lead off and snip the extra thing off. Why not do that? I don't know. I think that's what separates an average repair from a high quality repair, you know, going that little extra step just to make sure that you're not going to have any issues. Chances are you won't, but it doesn't hurt to get in there and do it. Yeah, the other thing too, cleaning flux residue off. You know, I can't tell you how many different repair jobs I've seen, and they just all the residues on there. Do I make them spotless? No. But it doesn't hurt to get some of that crud off the board. I don't use very active fluxes, so it's not going to like turn into battery acid and start chewing into the board, but it doesn't hurt to get in there and just get some of it off. That way if you have any little solder boogers or anything on there, you don't have to worry about them like, you know, rolling into something and shorting out, or it takes like a minute to clean the board. And then you almost guarantee that you get some of that rosin on your finger. So now I get to clean my hand too. Luckily it's made out of pine sap, which is weird, but whatever they extract out of the pine sap, it does a good job at making solder flow. Alright, board's recapped, glue is gone, transistor has been updated, the Q5. I'm not going to glue them in place right now or put any silicone on there. I want to get this thing tested first, so let's start putting this thing back together. Clean up my mess. Take a sip of coffee. I got this coffee heater on like Amazon. This thing's awesome. I can leave my cup down here all night and it'll stay hot. I used to be able to tolerate room temperature coffee, but I don't know, as I get older I like it less and less. My wife, on the other hand, that's all she drinks is like room temperature and iced coffee. She loves it. I can't stand it. Alright, let's fix this mess. So what I'm doing here is I'm just taking some of the extra thermal paste and just smearing it back into the center. Because they use way too freaking much thermal paste. You don't need this much. This is like, I don't know, you know, if any of you guys ever worked on a computer or a laptop and you changed a heatsink on it, and you have like the little shiny part of the chip that's on the top, and then the whole rest of the chip is covered in thermal paste. Like why? It doesn't do any good sitting on the side of the chip. I don't understand. Less is more. So quick recap, we started off with an amp that was at least good on the power supply. I don't know if it is good on the input board / preamp section. We're going to find that out real quickly here. If I don't lose all the screws putting it back together. We'll do a little oscilloscope test on this one just because I started early tonight and I'm having fun. Like I said, I was exhausted from work today and I took a little nap when I got home. Not something I generally do. I mean, typically I've always been able to stay up late, but I don't know, I've just been under so much stress and pressure. I haven't been motivated to really do any hobby work. I've just been kind of vegging out and hanging out with the wife. Watching way more TV than I would ever watch. I'm not a big TV watcher, but I've been watching a lot of TV lately. Just, you know, the ability to turn my mind off has been quite nice. Speaking of the wife, she's up and moving around. Alright, we're not going crazy with the screws, just a little snug. I always do the brass ones first and then the plastic ones after, just because it, you know, the plastic ones have a little bit more forgiveness in where they can move around too. I'll give this plate a little cleanup too. There's some residues on there. Clean it up, shine it up, make it look real nice for the guy. So I'm hoping that there was nothing wrong with the input section and we're just going to fire it up and everything's going to be happy and work. I mean, that's usually not the reality, but we're going to try. We got nothing to lose, right? I love this screwdriver. I need to go on eBay and find another one of these as a spare. This is probably the best Phillips money can buy. And it's older than my dad. That's the crazy thing about it. Well, maybe not, but maybe close to the same age. I don't know. Like I said, this is my great-great-grandfather's screwdriver that I somehow acquired. I love this thing. I mean, it bites into these screws like you wouldn't believe. And I'd shear the head off the screw before I'd strip this driver out. Some hard steel, whatever it is. Alright, let's see if we get light action on our input board here. If we get blue LED, I didn't break anything too bad. If I don't get blue LED, then I screwed something up. But we'll do our preliminary checks before I give it any audio or anything like that. So let's make sure I'm not going to spill anything. Turn our gain all the way down. Turn our low pass all the way up. We're on auto. Phase is at 0. Power is on. Alright. Uh-oh. Did I run over my probes? I did. Nice job, dummy. Let's make sure we have our voltages. There's another priceless tool here. The Radio Shack Multimeter, true RMS. I've always wanted a fluke, but flukes are generally cost prohibitive. I mean, I'm not spending a few $100s on a multimeter. When I got this one at Radio Shack when they were going out of business. You can still find them on eBay too, but it's a genuine RMS meter. And I think I paid like 35 bucks for this thing. I use it all the time. Alright, we're going to start off current limited 1 amp max. We got blue light, so that's good. Let's check our voltages now. So we have voltage going into our regulators. One of these is ground, obviously the one that makes the voltage show positive. So it doesn't really matter how you measure them, you just want to see your voltage there. And it's around 30 volts. Doesn't have to be at or above, just around. So we have power there, and then I always check these two front legs of the resistors here. And as long as we're close to 5 volts, that means that the dashboard is working. So we know one side of the secondary supply is working because we have 30 volts here. We know that the, I think it's class H power supply or whatever, the switching power supply for the outputs is also tracking and working because we have 5 volts. If you have a half a volt, the dashboard needs to be repaired. That's almost always that. Sometimes it's Q5, generally not. It's generally the dashboard. So we have all our voltages, so I'm happy with that. I didn't damage anything. I wasn't expecting to damage anything, but you know, you just got to check. So let's see, since the wife is awake, I can hook up an actual sub. So let's do that. Let's plug that in. I have this already hooked up into my little cheater scope here, along with the mess of other cables that I have floating around. I'm fairly certain this was a preventative maintenance job, but we are going to find out. Oh, my batteries are dead. I guess that's one of the downfalls of a battery-powered scope, is your batteries can die. Let's see, do I have a special plug for this? I need to be careful with my plugs because I blew up my audio signal generator by plugging in a 12-volt power adapter, and it only runs on 5. Luckily, I just smoked the LCD on it, and I was able to repair it. I think that was this guy here. But I was able to get a screen from Amazon, of all places. Alright, let's see what we got here. So, we got to give it some audio. Our volume is down right now. Everything else appears to be on and happy. I do have somewhat of a bad ground in this, so sometimes I gotta shake it a little bit. Too lazy to fix it. Alright, current limited, we're gonna start. I can see we have audio because my waveform changed. I don't know if I like that. Like, I have waveform, but something on there looks a little funky to me. Doesn't sound quite right either. It's not a pure sine wave, that's for sure. So something's definitely going on. I'm at 34 hertz right now. Let's bump it up to 100. That ain't right. Let's see if I can. It's hard to zoom in, but the sine wave is like tilted a little bit. It's not like pure and clean. And it doesn't sound right. It sounds like it's got a little bit of like distortion to it somehow. I don't like that. Phase switch is working. Low pass is working because I can see the amplitude changing as I dial it into the sweet spot. I wonder if it's a biasing issue. It could be, which means I'd have to remove that glue off. Let's see how hot it's getting. Sometimes that's a telltale too if something's wrong. No. Let's check our voltages. I can't hear what's going on in the mic. If that buzzing sound is really annoying, I'll go to silent speaker. So if the sound of the woofer is annoying, please say so in the comments if anybody's watching, and I will turn it off. Minus 6 volts, minus 6.5, and 6.1. So we're kind of close. I don't know if that's the right ground. Yeah, that's right. I guess we could check on the back side of these biasing resistors too. So we're at 6.05, negative 6.4. So they're pretty close. They're not going to be perfectly balanced because it's not a true dual output supply. Where is our distortion coming from? It looks like we got a diode in here that looks kind of questionable. A-okay, alright, thanks for letting me know. Yeah, if that sound gets annoying, tell me and I'll hook up my resistive load. So I'm zooming in on some of these parts in here just to see if anything on the board looks crazy. I can't tell if that's a blown diode or if there's just some gunk on it. I'm going to check my function generator. I don't think it's the function generator, but we'll look at the inputs. Actually, I'm going to fire up my good scope for this. I'll try and put it on the little baby scope, but I don't know if it's going to show up properly. I might need a little bit better of a picture to fully diagnose, but we will see. Alright, so we're going to hit our ground right here in the center as a big solder blob just falls off. Let's check here. Our voltage is going to have to go way down. So it looks pretty clean. It looks pretty clean going in. I don't really see any issue on either side. It definitely doesn't have that tilt to it. Let's see what it looks like going into the amp. Which pin is it? Let's try this one. That's it. Second one from the right. So going into the amp, it also looks very clean. Going out of the amp, it looks terrible. Well, now we know why this was sent in. So everything over here we can automatically rule out. Now we got to find out where and why our audio signal is hosed. Let's get that out of the way. I am going to go to the silent speaker just because the constant buzz is going to drive me insane. I don't like that sawtooth sound. I mean, it's not bad, but I'm going to leave the volume level somewhat moderate. Alright, let's see what it looks like. I got to make sure that I still get the same distorted waveform going through the dummy speaker. That don't look right. Am I missing something here? What's going on? It's only showing half of a waveform. Where is my other half? It's very possible that the speaker was generating my other half. Basically spoofing the signal on the scope. This looks like we only have one side of the output. Why? Why do we only have one side? Alright, let's see what we got going into the op amp. I'm going to pull a schematic up. These schematics can be found online. I'm not going to tell you where. You're going to have to learn how to use Google to find them, but they are readily available. That's all I will say. And the only reason I say that is because I don't want somebody calling me up with like a cease and desist because I'm providing private information to the public. But I have no problem putting them up on the camera here. But I will say that, you know, this is one of the few subs that you are able to get schematic diagrams for. Alright, we want the compressor circuit. And so, you know, if I don't have schematics, I generally make my own, at least enough to fix the problem I'm working on, and then when I work on another one, I'll add it, and it's just, it takes a lot of time. I don't do that on camera. This is the compressor. This is a preamp, this is the compressor. What the compressor does is it limits excursion, and there's another feature it does too. But it basically makes, you know, if you put too high of an audio signal in there, it forces the signal to not exceed a certain level, so you can't blow your woofer. I'm sure you can still blow your woofer, but it tries its best to protect it. So we have audio. This is U2, right? No, that's U3. It's not the compressor circuit. This is the drive circuit. I swear, I think there's a damn mouse in my house. Something is squeaking and it's driving me nuts. Either that or I have a fan going out on my server. One of the two. We'll address that when we get this done. Alright, let's make sure we're not getting too hot on my outputs. Alright, here we go. So we have this is a quad amp op amp, so I still need to get one more part of the circuit. But we should have out 1 and out 2, and the output of that is basically the drive for one half of that waveform. So we need to look and make sure that we're getting at least the input into the correct thing. So I'm going to look at R98, which connects to pin 6 of U3, and that'll make sure that out number 2, which is speaker plus, is working. And I think that should be working because according to our scope here, it looks like all we're getting is plus, we're not getting minus. So let's find R98, which probably is going to be hard to find because they're generally not marked. And that goes to pin 6. So let's see, I need my little plastic stick here. Don't stick metal on here when you're trying to poke around and count things. Alright, so R98 is going to be this resistor right here. Second one, let's zoom in. We got to zoom in. Alright, I'm not gonna get too close because then we're not gonna be able to see what's going on, but so this resistor should be R98. It could be R97 or R103. But it connects to pin 6, and that's what I'm interested in, is the connection to pin 6. So I want to see if we have audio. I'm going to look at this on my good scope. Well, hell, let's just put it on this one. Screw it. I'll put the audio signal on my good scope, and we'll troubleshoot it on the little cheap scope. How's that? That way everybody can see what's going on. Yeah, we're missing. It looks like we're missing the negative half of the waveform. Could be blown outputs. Highly doubtful because we're not getting hot on the outputs. Be careful when you're touching around in here too. Heatsink's okay to touch. Only touch one thing at a time if you're going to touch something. That's my rule. You know, there are hazardous voltages in here. So let's see. We need to turn our volume or our voltage down. Let's go to 0.5 volt and see what we get on pin 6. Pin 6. I get nothing. Oh, I'm getting nothing because it's not hooked up. Alright. Try again. Pin 6. And we're using our audio ground as our reference. And I'm not getting anything. So on the other side of that resistor, we're getting a clean waveform. And it could just be that there's not enough to measure on the other side of that. So let's look at the output. Output's going to be pin 7. Pin 7 is the last pin on the device. So we're getting something there. Pin 7, we're getting a little bit of a distorted waveform. Doesn't look as clean as it does as the signal going in, or whatever. Let's see. Yeah, the signal coming in looks good, or whatever's on the other side of this resistor. So this has to be R97 or it's got to be R98. I'm sorry, but you can see on the scope here, there's no like wonky distortion. Like if you look at this part of the waveform, it's just nice up and down, it's smooth. Even on the junky scope, it looks good. As soon as I go to pin 7, I have to turn the voltage down. I don't know why I'm not getting the picture now. There it is. Alright, we can kind of see it there. There's a little bump right in here. Like it's not as clean as it was on the other side. So something's going on with the waveform post op amp. So that means it's this side of the circuit. Alright, let's check our other one. By the way, these are the hardest problems to fix. Because you never really know what it is or how to, at least I don't. I mean, somebody that's well trained in this stuff probably be able to pinpoint it right away and be like, oh yeah, dummy, it's this right here, but that ain't me. Alright, we're going to check our R81 and then pin number 1. So I think R81 is this guy here, the top resistor. Alright, so if I'm looking on that, I mean, you can already, helps if I hit the right button here. We can see that I'm getting, you know, half the output. That's what I would expect it to look like on the other side. It should be that half. So if we go to the top, we get a weird looking waveform. If we go to the bottom, we're getting half. Let me get the other two sections of this op amp so we can understand the circuit and how it works a little better. This is U3. U1, U2, here's U3. Alright. So we should have two signals coming out of U3. Your audio signal comes in, it comes into this op amp, which is, I can't remember. If it goes into plus, it's either inverting or non-inverting. I don't know. One of these is inverting and one of these is non-inverting. So we should be able to see two waveforms on pin 9 and 14. It should be really clean sine waves, and they should be out of phase. There's no easy way to show that without getting out another set of probes and showing it on the scope. So let's just look at them and see what our waves look like on there. And I can't do an overlay on the cheap scope, so we got to look at pin 9 and 14. So if we look at pin 14, pin 14 is looks pretty good. I don't see anything weird on there that I don't like. It's showing 44 hertz. I'm putting 43 in there, but it's probably a resolution error on the cheap scope. Let's check pin 9. Pin 9 also looks pretty good. I kind of want to show, here, let's do this. I want to show you guys what this looks like. I don't know if I've shown that before. Let's just do it to do it. Let's see, I could take my probe off of here. Just because I have two probes out already. Hopefully my cord will be long enough. Use ground reference. And let's see if I can get in here and look at this. Pin 9. Let's get this dialed in. Give me a second just to get this on the scope so I can show what this is supposed to look like and with an actual good image. Alright, we're at 1 volt on both of them. Gotta be a little careful when you're poking around on pins in here. Oh yeah, that looks beautiful. Alright, now I gotta show you guys. Bear with me. Oh, my cord's long enough. Yeah, it should be. Am I gonna spill anything or make a mess? I know my desk is trashed. Learn to live with the messy desk. I'm gonna zoom out. Alright. So I have the lines, they're not perfectly phased, but you'll be able to see what this is supposed to look like. So we know going into the op amp we have good signal, and that's how you know. You have two sine waves that are perfectly matched, no distortion, and they're 180 degrees out of phase. So we know that at least the audio signal to that point is working exactly as it's supposed to work. I feel like it was worth showing you guys that. So now we got to figure out, so we know that in the whole amplifier, everything up until this point is good. So it has to do with the output sections, which is these two circuits, which is generally where the issues lie and why it's such a pain to figure it out. So we've worked through 90% of the amp. We just have the output. So now we got to figure out which side is bad and why it's bad. And I have a hunch why. It's usually a feedback issue. And I'm hoping that's what it is today, but we're not there yet. So let me get my audio signal back, put my probes back. And we'll try and figure this out. Well, I'm glad that this was sent to me with an actual issue and it wasn't just a preventative service, because I guess preventative service would have made the video kind of boring. Never connect your speaker outputs to your scope probe inputs. Always run them separate. Always, always, always. You got to do two separate scopes because they share different grounds and you will most likely blow something up. So we're getting a half wave on our output and it's the positive half. So I'm guessing that it's going to be the speaker minus side that's giving us the issues. So U1 is probably where we need to look. Somewhere in this circuit. Generally it's this feedback line that is missing or broken, or I'm going to do a little poking around. We're going to look on this scope here. Let me zoom back in and get the camera fixed. And we're going to figure out what's wrong with this thing. Come on, camera, focus up. Focus up. Alright, so I believe that this is R81. Do I have the right probe in there? No, I don't. Again, they don't have the silk screen on the board. You know, half of it's missing. So you don't really know what you're poking at. And who knows if, you know, the guy that was doing the layout on this board was drunk the day he did it. So on the one side coming in, it doesn't look too hot. And again, I don't know if this is R80. I mean, the audio signal comes in this way, there's a I don't really want to trace all these circuits out. It connects to a capacitor, so this, yeah, I think this is R80. Because that should be C49 and that should be ground. That looks right. Or, I'm sorry, 81. So it looks like the signal going back in to the op amp through R81 is just garbage. So we can try to cheat a little bit, and I can, you know, bend on these connections a little bit. Sometimes you get lucky and the signal will come back. Not always. So coming out of pin 1, I do see the same thing that I see on the output of my scope. Let's see here. That's on pin 2. Where's pin 2? Pin 2 is feedback. Going out of pin 1. Let's see what I have here. Gotta turn my voltage down. That's just ugly. It's almost a square wave. So something ain't right on that one. Let's check what we got going out of pin 7. Pin 7, we have a funky looking sine wave. And that makes more sense. Because the signal coming in doesn't get divided up until it goes through the other side of the op amp. So we got to check our feedback. And like I said, I still haven't figured out how to determine where the bad part of this circuit is by just looking at it. I know I need to get there, but I'm not there yet. But it looks like we're missing feedback. So that's what we're going to check first. So I'm going to power the amp down. And just for the heck of it, I'm going to hook my speaker into my scope. Because I want to know why I saw a completed wave there. That I don't understand yet. And I'm sure it's because the speaker is not like a pure load. So the cone is still moving in the other direction, so it's kind of like spoofing the signal. That's my guess, but let's see what happens. Gosh, that is ugly. Woof. And yeah, I think that's what it is. So we have a really strong positive wave and then like a little blip on the bottom. So it's not a true representation of what's going on. When I run it through the resistive load, since the resistors don't move, they can't hide, you know, any of that output information. What you see is what you get. Well, let's leave that off. We know what that looks like. I'm going to look on the board for any signs of foul play. And I'm going to check the feedback lines on this. So I'm looking for this point right here, which comes back through and goes to the op amp. So I don't know what R82 is. I do know that these lines do have a grounded connection on them, but sometimes these traces break and you lose feedback. And if not, then I'm going to probably check the outputs. It could be shorted outputs. Generally not though, because usually the amp runs pretty stressed and hot if the outputs are bad. Our voltages look somewhat decent, so I think it's got something to do with the circuitry in here. Let's check our feedback first. So I'm just looking for continuity on these sections. So when we go from the terminal back to the resistor, I want to make sure that trace isn't broken. And I'm going to do that on both the negative and the positive side. So we're going to start with speaker plus. Speaker plus is supposed to goes through this trace to here. Speaker plus seems to be okay. Let's try speaker minus. I got to get in here. Sorry, I got to put my head in the way, but I got to see where these tiny little traces go. So the speaker plus looks like it goes all the way back to here. And it does. Now both of them go to a capacitor. And that capacitor should go to this grounding stud. So we're going to make sure that those are both connected. So it's not a feedback issue. It could be a bad op amp. It's highly, highly unlikely that the op amp is bad. So now that tells me something else in here is bad. And it could be these, one of these pots acting up. I did do some glue scraping and exposed a couple traces here. Maybe I damaged a trace. We're going to look into that. I hope I didn't do any trace damage, but you never know. So let's do a little quick inspection here where I was poking around. Make sure that the so that trace comes to here. These things are hard to follow because there's a bunch of silk screen on the board. So it looks like we got decent connections. I'm just making sure nothing's broken. Those appear to be alright. So now it's down to probably a bad component, or our pots are bad. And the only way to check the pots is to get the glue off of them. I don't know, I might have some spares of those. I used to keep spares in my thing. Let's see what I got in the junkyard. If I have a couple of pots that are clean enough to just swap, I might just swap them out. Save myself a little bit of time. It looks like this board's going to have to get pulled again, unfortunately. I got one good pot, so that ain't going to work. I might be able to measure them. Yeah, let's pull the board back out. We'll just run the board off the bench. Because I do not know what is, that's not good. I saw that nut on the top of that thing spin. This is one of those crazy repairs. Like, I had a video on one of these. I was messing around with it for hours and hours and hours, and it ended up being a broken trace, so that's why I checked those traces right away. That still doesn't mean that it's not a broken trace. It could very well still be, but I want to get the plate out, and we'll start poking around and really digging into why. It's most likely a bad component somewhere. And checking that in circuit is going to be, for me, extremely hard to do. Strap yourselves in. Good thing I started early tonight. We're going to be here for a while. I guess when you had your bets that the repair is going to work out, it doesn't always work out. I'm not upset by it. This is, you know, we're all here to learn anyways, right? And it's not too hard to get these plates on and off. It's just a few screws. And I even have my external input box, so we will just run this open-faced on the bench. We know where the problem is, we just don't know what is causing it yet. It appears to be the negative side of the wave is missing. And it's kind of weird how this operates. Like the amp splits it up into two halves. I should draw this out. When we get this working, maybe I'll do that. I'll draw it out on the actual paper so we know what part of the circuit does what. I think that would help everybody, including myself. Come on, get that little locking tab in there. Locking tabs are the hardest part of taking the plate out. Sometimes they just don't want to come. This one, for whatever reason, is stuck. Came off before. Power is off, just so you know. We're being safe here. Yeah, I can't get this connector off. Oh, we're going to pry it off. Get a pair of needle nose. So sometimes these fast on connectors are just a nightmare to deal with, so you kind of got to brute force them a little bit. I mean, I'm hitting the locking tab, I'm making sure that it's unlocked, and it still just didn't want to come off. Sometimes they fight you. I don't know what to say about that there. Alright, so we're going to put the plate aside. Get rid of the plate. We ain't going to need that for a while. Throw that back in the box. Now, you guys probably won't have one of these, but this box here is basically the plate in a box, and it allows me to run the plate outside of the, or run the amp outside of the plate. It's just a preamp that I put into a little test box. I did this a long time ago, back when I had really no clue what I was doing, but I needed an easier way to test some of this stuff, so this is what I came up with. And it seems to work alright for what it is. But it allows me to poke around and check things. I don't know how to say your name, dude, but what's going on? Hello. I'm just going to call you Viet Hong, because that's the way it reads to me. If that's wrong or offensive, I apologize. It looks like Viet Hong, though. Alright. Now we can do a little more messing around and potentially shock ourselves, so you got to be a little more careful when it's not in the plate too. So we can give a current limited power, I can give it audio signal, and we'll verify that we have good audio signal and everything's happy and working and all that fun stuff. But this just makes it a little easier for me to see what's going on. Alright, so step one is going to be verifying audio signal. And I need audio ground. Where is my audio ground? I think it's pin 1 here. But I don't know what else that connects to. I know pin 2 is audio signal. Pin 1, I think, is the ground. I should probably just look that up so I'm not wasting a ton of time. Let's see what one ground is. Audio ground. Again, this is where having schematics is like a lifesaver. Feature board. Alright, looks like ground is shared with the plus-minus 15 ground. So the op-amp ground is our audio ground. So that's going to be That's going to be this pin over here in between the two power supplies. I don't know exactly which one's pin 1. I'm just calling pin 1 the pin that's on the left side. Put it into continuity mode so I can hear what the hell I'm doing. So, alright, so we're going to clip our scope probe onto this voltage regulator heatsink, and that's going to be our audio ground reference. There's no scope probe connection on these boards. Let's get our silent speaker hooked back up. And then we're going to start diagnosing what the heck's going on with this thing. So let's fire it back up, current limited. Let's look at our audio signal coming in, possibly. Not getting anything. Why not? Do we have power? Do we have audio? Oh, I don't have. Need some volume. Why am I not seeing anything, or what am I doing wrong? Let's see if we have power. And my box could be doing weird stuff too. I can't rule that out. Well, we got power. We have voltage. My probe is connected. It's on 1x. Should be correct. Where's my audio in my box here? I never labeled this thing, so I'm always putting the switches wrong and all that. So let's bear with me here. I want both switches to the left. Low pass is the bottom one. That should be all the way up. And yeah, this one closest to me is volume. Function generator is on. I should be getting some audio here. If not, I'll just get another board. I don't know why it's not showing me anything. What am I doing wrong here? Let's try this. Let's get an actual audio ground and see if we get anything that way. I haven't used this box in a while, so I don't know if it's working or not or what's going on. I know it has power. Let me see if I have another preamp board. I do. I have a whole nother plate. Conveniently out of a SUB-12. Well, if I have to, I will steal the cable out of the one and pop it into the other one. I don't know why it's not working though. If I have to, I'll just set it inside the other plate and we'll just test it that way. But I was hoping my little remote box would work here so I could get some scope traces. Let's see, is it? Yeah, it's not the scope. If I touch it with my fingers, I get some stuff on there. So I should be getting audio signal to the audio pin, which is this guy. Crickets. Getting voltage on the voltage pins. Oh, I think my little control box is dead. I must have killed it somehow. Oh well. We tried. Let's throw it on this other plate. I know this plate is good. And it doesn't have any crap on there, so I don't have to worry about getting goop on. It sucks that I have to put it back on a plate, but I don't want to take time to rebuild my little testing thingy right now. I want to fix this so you guys can figure out how to fix yours. Here, I wonder if I could just do this and set it off to the side. That might work. Alright, we want it on, phase at 0, low pass all the way up, gain all the way down. I'm running out of room rapidly in my chaos. Alright. Give me an audio signal. Nothing. I got my inputs. Something is not right here. Let's see what we got going into our box. We got signal. I can see it. You guys can see it. I'm not crazy. Why are we not getting any? It must mean our ground reference is off. Our audio ground. I thought audio ground was... Well, it's powered on right now, so it's not going to give me anything accurate. Let's try that again. Audio ground should be the common. I'm going to let the voltage and the supplies die down. It's going to give me false results. Yeah, this right voltage regulator is the audio ground, according to the schematic. We're not getting any audio input. That is concerning. That means there could be a short somewhere. I'm not setting this thing on screws or metal, am I? No. Why am I not getting any audio in now? I'm not getting any audio in, and I'm not getting any audio out. Something changed. We checked, we have power. Let's check the plus minus 15. You guys probably won't be able to read this, but I'm just going to do a quick sanity check just to make sure that the voltages are good. So here's ground. Plus 14.8. Minus 14.8. Power supplies are good. So we're getting power to the preamp. I have my blue line hooked up into here. Did I flip the switch on here? We're looking DC signal. I should be getting something coming out of this preamp. That's ground, audio ground. And that pin right there should be audio signal. Nothing. Well, maybe this preamp that I grabbed is junk. It's very possible that the preamp I grabbed is garbage. 0 for 2 though seems kind of odd. Well, let's try the original one. I can't imagine 0 for... Let me see, I might have one more of these somewhere. Now, let's go back to the original. Maybe it just maybe I have two bad ones. Unlikely, but I don't want to rule it out until I know for sure. And if I do, my next project for tonight is going to be fixing my little test rig, because I can't do testing if my equipment's not working. Alright, so we have our RCAs plugged in. Try again. This time with the actual plate. So volume's at minimum right now. We have no signal. Power's on. Yeah, so I have two bad preamps. That's what it boils down to. Either that or the pinouts are different between this one and mine. That's possible too. I didn't check that. But it appears so we'll just use the original one. That's fine. I'll just set this off to the side, and we'll use that to poke around. Remember, we're hot here, so I'm grabbing one thing at a time as I hold onto the plate, but one thing at a time. This would be connected to the plate, so. Alright, let's see what we got here. We have audio coming in. We're back at a good place. We have pin 14, we got good sine wave. Pin 1, we have good sine wave. Or, I'm sorry, pin 8. So that takes us back to these schematics here. Now we can start troubleshooting what the heck is going on and why. So let's look. We'll start with. We're going to start with speaker minus, because you know what? I missed something. So here's something to pay attention to. I'm looking at the wave on my scope, and I didn't observe the polarity of these wires before. And that's important. So my gold wire, or copper colored wire, is speaker positive. I don't know if I had those connected in right last time, but I'm looking on my scope, and I'm showing that I'm getting the negative side of the audio wave, and I'm missing the positive. That's an important thing. So when you're connecting your scope up to your outputs, and again, it's got to be an isolated scope. You can't look at the output and the input at the same time. Okay, so we're missing the positive side. So that explains what we were seeing a little better. So let's go back to pin 7, which is down here. And that's where we had that funky looking sine wave. And then when I go to pin 6, which is this resistor here, we had a good clean sine wave. So looks like coming in, we have good, going out is bad on the positive side. Because I'm pretty sure we should only have half of a wave coming out. And I know this little scope's a pain in the ass, but so yeah, it looks like garbage coming out, and it's a full wave. Now let's go to the negative side, which appears to be working correctly now that we have our scope leads hooked up right. And if we look at the signal coming in, we have that half wave. It looks a little funky on the top of that, but So we got to focus on the positive side. And figure out where our feedback is getting screwed up. So the two pots adjust the bias for the waveforms, and what that does is, let's see, let me go to a good waveform here and zoom it in. So we can see a clean waveform on the scope. If you cut that in half straight across, there's a positive side, which would be that, and then you have the negative side, which would be that. And what the bias does is, since the way that the circuit's designed is it chops it up into two pieces, the bias adjustments align those two pieces so that the waveform is continuous and you don't get any distortion in between. So if there's any shifting or offset in there, you know that's coming from these pots here. So that's what this circuit does. It just kind of shifts the waveform back and forth. I'm not convinced it's a biasing issue. I still think it's some sort of a feedback related issue. So we're going to have to check our feedback resistors. I'm going to check them both. Should be 64.9K. That's R82 and R103. I have no clue where those are on the board. I do have a deconstructed board, so let's dig that out. That might help us a little bit. Then we're going to have to step through this one at a time. I had a better deconstructed board somewhere, but at least we can get into this one and kind of see what's going on. I'm going to get this light out of the way because it's blinding me. So at least we can, we can use this as a sub-10, but they're pretty much the same, so we can use this to help find some of our signal anomalies. It's probably going to end up being a resistor or something really stupid. So I'm going to go power off. And we're going to have to dig around and we're going to look for these feedback resistors and measure them. Make sure they're, not blown or out of spec or shorted or something stupid. I hope this doesn't come down to being a broken trace again. It very well could. I just hope it doesn't. So feedback for speaker plus. Now I gotta follow the trace. So it goes between two different components. And this says 3921 and that one says 3921. So that's what, 39.2. Okay. I don't see that anywhere on here. Let's see what the sub. This is a sub-12 schematic actually. Where is that resistor? 3. Okay, that's 3.92K. So that's R88 and 89. Well, let's measure those just to see if they're working or not. Of course, measuring in circuit's gonna suck. These are only reading 2K, but they're in series with a capacitor, so that's gonna throw it all out of whack. So it should be 3.92K. So one of the things you can do to cheat that a little bit is to power is off, by the way. Take your tweezers and short them out. That drains the caps, and then remeasure. I'm getting 2.4 and it's climbing because it's charging the cap. So I don't think these two are bad. We're just going to keep stepping through. I really want to measure the pots, so we can do that. I'll show you a trick to do that. We're just going to flip the board over, and I'm not really concerned with what the value of the pot is set to. I'm concerned if the whole pot has value, and then we'll look at what it's set to. So if we flip the plate over, and our two pots are here. If you just go between the two ends, that's a really crappy factory solder joint right there. So I'm getting 213 ohms. And our pot should be 500. But it's in circuit, so you gotta give it a little leeway, because there's other stuff connected to it. It's got some diodes and stuff connected to it. Both of them are reading about 220 ohms. So let's see if we go to the wiper. This one's reading 0. Going to the wiper, that's not good. Let's see what this one reads. That one also reads 0. Let's try the other. Two of these legs might be shorted. They are. Pins 2 and 3 are shorted. So the ones that show 0 are pins 2 and 3. So it's just basically a one-way pot. So we're reading 224. So the pot is set at 224. So 224 and 213. So we know right away that our pots are good. They're at least, set to some value. You can't read total value because if you look, the wiper's shorted to pin 3, so you won't be able to read the 500 ohms. But we're getting, around 200 and change, so we know that at least some adjustments happening out of those. So the pots are not bad. That's not the issue. And I know we had some glue there, so that could have been a place for concern. So now it comes down to, keep searching. Again, I don't want to think it's the outputs. That doesn't mean it's not the outputs. It very well could be. These intermittent sound issues are a pain. And let's see, I do have a good amp. We could poke around on a good amp and get a side-by-side. Maybe we'll do that. Maybe that'll be our next step. See where we're actually, where we're missing, and see if we can figure out why. That might speed it up a little bit. So let's clip this back up, power it up, and look at what we got, and then we'll compare that to what we're supposed to be getting. Power is back on. We have a signal going in. We're going to look at pin 1. So pin 1, we're getting a square wave coming out of it, basically. It just pops right up and it does behave. Pin 7, we're getting a much lower voltage waveform. It looks really ugly, but we're getting a waveform nonetheless. So we're getting something much higher out of this little scope's driving me nuts. There we go. So yeah, it's dropping way down and like clipping and coming back up out of pin 1. So that's what we're getting out of this one. So let's shut this down. I'll make sure that I connect our dummy load up. It's still running cool, so we're good there. Put that aside. Bring in this guy here. I need a bash board. I don't have a bash board. That guy I know is broken. That guy doesn't have one. I know I have a bash board, I just don't know where it is right now. Let's see. Klipsch spare parts. I don't know if this is the right one, but it's a bash board nonetheless. I got 2 of them. Let's see. This is a RD Rev. What is the one that is supposed to be in here? This is an RA. Well, it'll still work. It'll just be a little bit shifted. Hopefully that's a good one. I made this board with sockets so I can do like little crude testing like this. That's weird. Why is the plug on... So I know why my little box isn't working. So on my board, the connector is facing with the slots going this way. On the customer's board, they're facing the other way. So there's been 2 different revisions of that as well. But I know the pinouts are exactly the same, so what I'm going to do is try to pry mine off. That's why my preamp wasn't working, so I'm going to have to make an adapter harness for that. See, we're learning stuff every night. Even I'm still learning stuff. Why the hell would they have 2 different connections going to the same darn board? Shame on them. Alright, so if I flip this around, his preamp will work with my board. I've never paid attention to that. I've worked on a ton of these. And never really saw that the connectors can be flipped around, so I'm going to have to pay attention to that. Stupid little things like that can really throw you off. So there's probably nothing wrong with my 2 preamp boards. It's just the way that they were slotted in the connections there. I'm expecting to see a good audio output from this one. And this plate amp's been through the war. I mean, I didn't recap it or anything. This is just purely a testing platform, and I use it to test PDC and bash boards. That's it. It's been blown up multiple times. I mean, this is just a quick and dirty, let's, get some data out of it type of thing. Hopefully it's working right now. We will see. Oh, it ain't gonna work if I don't have any power plugged in, dummy. Told you I was rusty. I wasn't lying. Alright, we're going current limited still, because this thing is quite unpredictable. Could just nuke itself right here. Alright. Clean wave coming into our op amp here. Let's look at pin 7. So pin 7 has kind of that funky looking like rounded sine wave. And I'm going to guess pin 1 has the same thing. So it does. So if I look on the good side of those two resistors we were checking earlier, if I can, so we have good wave there. Good clean side wave coming in, coming out. Might be too low of a signal level to even read it. Let's see if I can get in pin 6 here. Yeah, I can't, the scope won't pick that up. So we want funky looking distorted waveform coming out of our op amp. And on the pin 1 side, we were not getting funky looking waveform. So good waveform in, funky looking waveform out. I mean, it's basically a sine wave, it's just got a little bit of distortion to it. So we were getting a square wave, so we know where the problem is. Tester amp to the rescue. I did have my leads plugged in backwards, but we weren't looking at, well, let me look at waveform output anyways. Pure sine wave, like beautiful, beautiful pure sine wave. Even though these are backwards, it doesn't matter because it's working. Alright, step in the right direction. I love this board. Like, I really, really love this board. This thing has saved me numerous times when I've been super stumped. And now that I know that these connections are weird, it's going to save me a lot more. So just to show that, this is a SUB-12 board that's been just severely damaged, and I'm working on bringing it back. This has the connector mounted the other way on it. This is the one that we're working on tonight. This has the connector going the other. The slots are on this side. This one has the slots on the wrong side. Same exact amp, two different connection styles. I assume that has to do with the input boards on some of these. Some of them the connector's on one side, some of them they put the connector on the other side. Why? All that does is screw us up. Alright. We're cooking with some gas now. We know where we need to be. Now we gotta find out how to get there. I need some electric nerds in this chat here that can say, oh yeah, just check this diode right there. I haven't achieved full nerd status yet. I'm still working on it. We'll get there. Might take a few years, but alright, power's in. Everything's hooked up. Flip her on. And let's look at our signals here. So we got good sound coming in. Yeah, it's as good as it's going to get. Coming out on the bottom, we're looking pretty good. Coming out on the top, we are looking bad. I don't know what that is. That's different. Oh, I have no output. Well, actually, that might be good. Let's see what's... We can see what's going on without any output plugged in. Which means there won't be any feedback flowing through. Bottom half is working. So we're getting some funky noise in pin 2. Pin 3 should be quiet. Alright. Where are we at here? So what is on the negative side that's not behaving? And we can see, I don't even know what that is. Like, I can zoom out on the voltage a little bit. Alright, so we're getting something, but it's just like a really jacked up. Let's give it some more volume. Since I don't have a load hooked up, it's not going to burn anything out. I mean, these guys might start getting hot if there's a shorted one, but I don't think it's a blown output. I think it's something else. I think it's something. Let's see here. Speaker plus looks okay. Speaker minus looks not okay. I should have checked that on the other one, if we're supposed to get a full waveform with reference to ground. Now you can check it like this, because I'm only checking one side at a time, and my ground is referenced off of a different line. But you can't take speaker minus and hook it up to that. That will not work. I mean, speaker plus looks really good. Speaker minus looks half good. I'm pretty sure speaker plus is only supposed to be half good, though. Darn it, I don't remember. We gotta get the other plate back out and look. If we reference off of ground, what is it supposed to look like? This is why that dummy amp is gonna really come in handy. I think it's only supposed to be half the wave. But I can't remember, and I don't know, so we're gonna find out. I think with reference to audio ground, I think it's only half wave for plus and half wave for minus, and then they're supposed to be out of phase, 180 degrees, and then they get recombined basically at the speaker. We're going to find out right now. What do we got? Nope, on here we have full sine wave and full sine wave with reference to audio ground. And they both look beautiful. And I'm pretty sure they're out of phase with one another. Alright, so now we know what side is bad. Now we gotta fix it. Let's get to it. I thought something felt hot there, but it didn't. It's okay. Alright. So basically what's going to happen is we're going to find out what this is, and then I'll update the description of the video, like with the symptoms, and hopefully that'll narrow it down and help somebody that's having one of these funky weird issues. It's definitely in the audio path. It's possible it's a bad output now. I'm not gonna rule that out anymore. Now I'm gonna say it's possible. Still unlikely, but possible. All right. So speaker plus looks good. Speaker minus bad. Speaker minus is the pin 1 side. That's where we were seeing the really weird signals. So let's see, we're going in, we're looking alright. I'm checking the op amp too, making sure the op amp's not getting crazy hot. It's generally never the op amp. I don't want to rule it out for sure, but I think it's somewhere in the feedback side. I don't know enough about op amps to to know what's really going on there, but what we could do is we could take the feedback. Oh no, you can't take the feedback out, because then that's what sets the gain. We got to find that resistor and make sure that resistor is good. That's R82 64.9K. Let's look on this board here and see where they go. So I'm looking on my dummy board. I'll point it out in the video. So it goes to multiple spots. Speaker minus. My two power resistors are getting real hot. I mean, he's put out some heat, but that's a little hot. I mean, I guess the other ones were getting warm too, but let's check my voltages on that again. See if one side's sagging way down with some volume up. I think we can safely say that, let's see, we can go off of here. 14.28. 14 points. So it's if one of the outputs was bad, you know, one of the sides of the supply would be just totally drained down. I mean, I know these run a little bit warm in operation, but it feels hotter than they would normally be. I can't say for sure. I know they do get warm. We gotta check this resistor on our feedback. So I need to find out where R82 is. I lost my magnifying glass, darn it. There it is. R82. Now it's probably one of the ones that's not marked. There's R80, R81. The board I'm looking at has better markings than the one that I'm currently using, so that's why I'm looking at these. So there's R80. I found R82, 64.92K. And this says it's 64K9. R82 is right next to our adjustment pot. So I'm going to power down, and we're going to see if that resistor is good. I'm going to go into ohms mode, and it's probably not going to read what it should, but we've got to keep in mind it is in circuit. And I'm getting 65K, so 64.9, 64.8. So it's not our feedback, at least not the resistor, but I do want to make sure that that is connected. So let's, yeah, it is. It's connected on one side. So it's not a missing trace. And that goes to those two other resistors, R88 and 89. Connects to both of those. So that looks good. We won't get a good measurement on those, but I can try it. Make sure those aren't blown. So it's going to come down to testing parts and finding out which parts are bad on the... Getting 3.1K on that guy. 3K. So it looks like R88 and 89 are good. We know our pot's good. Let's see, we should have plus minus 15 volts going in for the gate drives. And I'm sorry, I'm just rambling on. I'm just trying to see what could be screwing this up. I'm going to check R87 and I'm going to check all these resistors coming in off the power supplies, making sure we're getting power coming in there. Because we should be getting 15 volts coming to D17. And we should be getting negative 15 going to R86 and R90. And I'll check those resistors too, just to make sure that they're good. So R90. Let's see, R80, R81, R89. Where's R90? R90. R90 is... Oh, it's labeled on this board too. Alright, R90. Let's make sure he's good. 1.79, I think it's supposed to be 2K. That's probably good. R87 should be somewhere in this mix. There it is. I'm just making sure that none of these values are just totally off in the weeds, because that would screw up the operation of how this thing works. R83, 500 ohm, 511, that one's good. So we need R86. R86. $511, that looks good. I'm going to double check these traces where I was scraping again. Make sure I didn't totally screw something up. Because it's generally a broken trace. So I'm going to check all of the leads coming out of the pots and going to the board. I would not be one bit surprised if this is something that I totally screwed up. Trying to clean that glue out. But I just, I want to make sure. I want to make sure it's not my doing. D27 looks a little suspect right now. Nope, it ain't that. Let's see, where does this guy go? So it doesn't appear to be any trace damage, at least that I can see. There's only 4 traces in that area where I was scraping. There's actually one more off to the side, but I doubt that's the problem. But just as a sanity check to make sure I didn't do anything stupid, I'm checking continuity where the traces are, because sometimes that glue can stick to things and cause some damage. Unlikely, but it's always possible. I'm gonna look at the transistors and diodes under a magnifying glass. I'm doing that just to see if anything looks burnt. Sometimes you can see like a little blister or something on one of them if they popped or went bad, or they look really discolored. Generally if it's an issue with one of the devices, you can usually see it. Not always, but usually. This one trace here looks just a little suspect to me, so I'm gonna make sure we get negative or positive. One of the voltages goes to R107 here. Make sure I didn't break that. No, that looks good. All our connections and traces look good. It does not appear to be a shorted output, because if the output was shorted, it would not behave at all. So that leaves a component failure. I don't want, I guess if you really get into a pinch and you're totally stumped, you can just start replacing everything. I still don't think it's the op amp. I think it's something else on this board. And there's no easy way to replace this op amp. You got to cut it off and put a new one on there, and I don't think I even have any of them, to be honest. And to my memory, I can't recall a time when I replaced that op amp and that actually solved the problem. I don't want to fully rule it out yet, but I also don't want to say that that's what it is. So we know we're not getting good signal going out. We know we're getting good signal going in. C49, just for the heck of it, let's make sure that cap didn't go bad. That's not a likely cause either, but we might as well check it. C49, that's that guy right there. Sometimes these cheap Chinese caps do go bad. I've seen it happen. So I'm measuring about 80K on that. Getting 10K on my deconstructed board. Let's see what I'm getting on my evaluation board. Getting about 80K, so the capacitor is generally not bad. The only way to test in circuit is honestly to compare to another board. Otherwise, you got to pull all these parts off and individually measure them. So if I can compare that to another board, I can kind of hone in. And the other thing we can do here, since I do have this secondary board, and we do know that this board works, is we'll just measure across all. I'm just going to do ohms, measure across each component, pick two legs and compare it, pick two legs and compare it, and if there's a bad part, generally that will show up as a discrepancy on the resistance. Not always, but sometimes. So let's just dig through. I really should wash this board. Just take it right to the sink and wash it. And I've done that before, and you know what? It doesn't hurt the board one bit. A little bit of Dawn and a toothbrush will shine this baby right up. Alright. So right now I'm checking R84 on the good board. It's about 525 ohms. Let's see what we got on this guy. Okay, well that ain't good because I'm reading 40. I was reading 40 meg. Let's try that again. 560. I'm going to short that out. Power is off. I'm not getting anything across R84. Could it be a bad resistor? 539 ohms. What's that supposed to be? R84 should be 511. I'm not getting anything on this guy. When I put my fingers on, I do. It's just reading open. Alright, that's weird. I don't want to say it's bad yet, but it's weird. Let's check R85 and see what R85 shows. If R85 gives us like our 500 and close to 12, I'm going to say then there's a good chance that maybe R84 is a bad resistor. That would be a first. Usually resistors do not go bad, but I mean, it doesn't mean they can't. Weird. Let's see, I gotta find R85. There it is, right here. We'll check it on trash board. 530 ohms. We'll check it on dirty board. 539, and we'll check it on this guy here. 540. So now let's go back to R84. Nothing. Nothing but a waste of time. Alright, so just to verify that this is not behaving, I'm going to resolder it back in place. Just put a little blob on each side, because you know sometimes you get oxides and crap on there, and that throws you off. So I want to rule out that it's a bad solder joint. That still don't mean that this is the problem. But it's real weird that that is reading open with fresh solder on it. Alright. Time to pull this resistor off. Maybe we found our problem. Bogus Chinese resistor. I shouldn't say that. I mean, China resistors are usually pretty good. We're going to scrap that part. He is dead to us. Even if it's not a good part, I'm just going to pull one off a donor board and replace it. So I need my solder wick. Let's clean up them pads. That'd be great if that, you know, it just turns out to be a resistor. Again, this would be a very, very isolated case. I can't say I've ever seen anything like that before. And I'm positive I don't have one of those, so we're going to steal one off of a donor board. I should have plenty of those on here. Yeah, there's one. Let's find the easiest one to remove. R100, that looks good. I think I'm going to hot air it. Let's go, let's set the temp to 375. That's probably a little too hot, but I want it to come off, so. Especially since this is lead free. Alright, we got ourselves a donor resistor. Probably hot as hell. I'm going to burn my fingers. Alright. Just going to verify the value before I put it in. It should be 511, so I think we're good. I'm not going to hot air put it back on. I'll just solder it back in with my fine tip. I'm just going to double check that it's the right value. 5110, alright. Doesn't hurt to double check. What a silly problem if that's a bad resistor. How the heck does a resistor go bad in a op-amp feedback circuit? I'd like to know that. That's a fresh one for me. But hey, we're working the problem. That's what we're here for. We're here to learn. I always solder one side at a time when I'm doing surface mounts by hand. I like to make sure that I get it, you know, nice and square on the pads. It really helps if you don't pull your tweezers away too soon, like I repeatedly keep on doing. Alright. And then I push down with my fingernail and heat it up and burn myself and make sure it's dropped to the board. I tend to over solder them when I solder them by hand, you know, but who cares? You know it ain't going to come off or have any issues. Alright, let's see if we get our 530 ohms now across our resistor that we just replaced. Alright, that's looking way better. So I'm getting 512 there off of 84. Let's check our 85 again. 510. I think we found our problem. If I would have measured all the resistors and instead of just jumping around, I probably would have found it a little bit faster. But you know what? Like, I wanted to do some probing and testing first. But anyways, you know, hopefully this is the issue and it'll solve it. The amp will come back to life and start playing music again. The more important thing though is we learned something tonight, or at least I did, that these connectors are not the same. And that's I think that's critical because I'm pretty sure I have damaged this my little tester box once before. And I'd like to fix that and never do that again, so I need to figure out either I need to make like a little adapter harness or I need to change this so there's two connectors on there, one facing out and one facing in, and mark them. Maybe put like a little Y cable on there or something, I don't know. But I need a way to be able to use my little test box with that. Alright, let's see what we get now. We put that resistor back in. Like I said, it's usually not the op amp, and it's usually not the pots. So hopefully it was just that goofy resistor was failed for some reason, and we'll have output. Let's see what we get. All right, let's turn our power on. Everything looks clear. We're not going to short anything out. Moment of truth. Speaker plus, sine wave. Speaker minus, sine wave. Boom. Yes. R84. Alright. Well, let's check our outputs on the op amp now. Nice looking sine wave on pin 7. Nice looking sine wave on pin 1. Boom. I'm happy. We're not done yet. I still got to put it together and we got to do a final test and a speaker test. But let's look at the schematic really quick and figure out what the hell went on. So R84 is right here. So our signal comes out of our op amp as a sine wave. Then it gets converted into a half wave. I don't know which side is positive. Let's see, positive. So, yeah, this side should be the positive, this side should be the negative, and then it gets fed to our, these are our actual MOSFETs for the output. What the hell would cause that to fail? It didn't fail from burning because it didn't look burnt. So it wasn't a ton of current being drawn through it. It had to be a defective part. Because in order for this thing to fail, you would have to pull a ton of current through that. Which means there would either have to be a short between this whole side, which doesn't seem likely. I mean, well, actually that's not true, and I'll tell you why. If you remember when we started out, there was brown glue on the board by these pots. Well, it just so happens that these pots are located, right in this circuit. You got plus and minus 15 volts coming in. It's very possible that that short caused both of these transistors to turn on, and it pulled excessive current through R84 and caused the short. That's what I'm going to guess happened. Now that I think about it, I think it was the glue, and the glue caused that guy to die. I don't know why it didn't look burnt though. Maybe it died a slow death. I'm not sure, but that's my theory. I don't know. I can't prove that, but I'm gonna guess that the glue caused both of these two transistors to turn on somehow, and that just allowed 15 volts to just, what would it be, 30 plus minus 15. It allowed excessive current to go through and kill that resistor. That's my guess. I'm probably wrong, but nobody will ever be able to determine that, so I guess by default I can say I'm right. Either way, we got this amp fixed, so I'm excited. And I didn't have to tear a whole bunch of stuff apart. Let's leave that in there. We'll pull this from here. Alright, let's get rid of this power cord. We'll go, is this, yeah, this is the customer plate. I'll make sure I don't get switched out with one of mine. Do something dumb. Dang, we're 3 hours and 48 minutes in. Oh well, that happens. We learned something though. That makes me happy. We learned something and we fixed an amp. 10-cent resistor, causing the audio to sound like garbage. I want to see beautiful sine waves. I am looking forward to it. I'm going to do another plate tonight. Might as well. I'm feeling froggy still. I took a nap. I got to get rid of that squeaking sound though. One of my computer fans is totally wigging out, and if I have to listen to that for another 10 minutes, I'm going to start smashing things. It sounds like a mouse that's like trapped in a bucket and just squealing like to be rescued. Terrible sound. Alright, let's get our plastic screws in. And then we will put our heatsink screws in, plug this bad boy in and do a little testing on it. And then get it back in the box and move on. Plastic screws piss me off. Klipsch couldn't spend another $3 on standoffs. Come on. think my box was open. It caught that screw that was about to go flying off. R84. It's got to be the glue. It's got to be. What else would it be? Glue was right in that area. It was turning brown, probably coming conductive. Had to be the glue. I mean, there's probably a couple other things it could be, but either super cheap resistor, possible but unlikely. I mean, I'm pretty sure they are cheap resistors, but even cheap resistors are usually pretty good resistors. I'm going to say it was an excessive current draw that somehow passed through that. Part of the circuit, it cooked that resistor. That resistor failed to open, which means that the circuit was not operating. Only half the circuit was operating, which is why we only saw half of the wave. I don't know how I think they had this curled over the top and plugged in. A dumb way to do it, whatever. Alright, let's hook this into our silent speaker, because I'm sure the wife is sleeping again. We're going to go plus to plus and minus to minus, even though I know it doesn't matter right now. Sucks this one took a little bit longer to repair than I would have liked, but hey, we fixed it. And I learned something. Something that I can apply to one of the other amps that I'm having trouble with, which is this guy right here. Alright, power's on, phase is 0, low pass, gain's down. Let's go into this little guy. I can put this probe back in his bag, put him away. We don't need 2 probes anymore. I can turn off my good scope. Just give me a second to get organized here, and then we're going to fire this bad boy up and obtain victory. Alright. I gotta try and stay a little bit organized. My desk is disaster, so every little bit helps. Let's go to our battery scope. Alright, silent speaker is hooked up. Scope is hooked up. Power on. Power is not on because we're not plugged in. This cord has been a little damaged here. It's not through the insulation, but it's close. I might put a little E6000 on that, glue that back up. Alright, try again. Now we have power. Ooh, I can see sine wave already. Moment of truth. Oh, there it is. There it is. And it looks good. Let's zoom in. We're going to go full power on the amp so I don't brown out. Focus. Well, that's about as good as it's gonna get. Alright, let's crank this bad boy up. We need to fatten that wave out a little bit. That is what this amp is supposed to do. That is a beautiful sine wave. Ignore the, I'm about 1 hertz off, but that's because of the time base. If I zoom in and get a little more data on the screen, it corrects itself. But that is what you want to see out of a sub-10 and a sub-12. That, I mean, that is a beautiful, clean. I mean, that's crystal clear. It doesn't get better than that. Let's do a little sweep. We'll go a little up in the hertz. We'll take it up to 100. And I mean, this is a crappy scope. If I had this on the Rigol, I mean, it would look even better. But it looks pretty damn good on here. I mean, there is no fuzz, no distortion, no nothing. Gotta turn the volume down a little bit. Peeking out a little bit. Let's see, we're at 31 hertz. Now we're down to 15 hertz. Like I said, ignore what that's showing because there's not enough data points to get a good reading on there. But I mean, through the whole frequency sweep, she's looking good. Time to get that transistor epoxied in. Get the caps secured in place with some silicone, and get this amp back to the owner. Done. This bad boy is working good. My load's getting nice and blazing hot, so it's putting out some wattage. We're running at 4 ohms right now, and it's, you know, stable at 4 ohms, so I'm sure it's getting a little warm. Oh yeah. Oh yeah. Nice and toasty. We're pushing it hard, and it looks good. Power off. R84. I'm calling it R84, and I'm calling it glue damage. Alright. Oh, where's my buttons at here? So I can talk to y'all. There we go. I know this was, you know, it was a little dragged on, a little bit lengthy video. You know, I thought it was going to be a quick fix. And one of the reasons why I don't test a lot of these amps before I get started out is because I don't really like always knowing what I'm in for. So it's kind of fun doing the preventative maintenance first, and then, you know, waiting for the surprise to see if it works or not. You know, like, I expect most of them to work, and, you know, when it doesn't, you know, the immediate hit is like a bummer, but then, like, working the problem and actually figuring out what is wrong and getting it back up and going is it's fun. It's challenging and fun. Sometimes it's frustrating, sure, but I enjoy it. I really do. I enjoy, you know, doing this in my free time when I have time. But you know, this is somebody's piece of gear. Now they're gonna get to throw it in their house. They're gonna get to enjoy it, watch their movies, or listen to their music, and, you know, so it pleases me to do that, I guess, is what I'm saying. So, you know, this is a weird issue. I can't say I've seen this issue before. My theory again is a glue failure, or glue caused the failure. I can't really think of anything else that would cause that issue to happen. So, we learned a couple things tonight. We learned that there are different connections for the input box. I'm going to have to rebuild my little controller that I made. I might do a small little video on that. I'm not sure. I have to test it first and see what's going on. But bottom line, we got this amp prepared. It's only, we'll call it 130 right now. I got to get rid of that squeaking sound that's happening. Excuse me, on my computer fans on the other room. Like, if that keeps going, I'm going to lose my mind. So, If that doesn't take too long, I'm going to come back and do another repair. If not, I'm definitely going to be back tomorrow because I got to get a shipment out of, a big shipment out on Monday. So bear with me. Hopefully I'll see you soon. I'm going to update the title in this video, and we'll see you guys for the next one. Please remember, like and subscribe, and I'll see you then. All right.